Hello guys, welcome again to this channel. This is G Solutions, where we find solutions for your needs. So today we will solve the circuit problem in alternating current. Circuit problem with impedances, and according to the problem, in the circuit shown, what is the voltage supplied if the voltage across Z1 is 60 cis of 0 degree volts. So determine the current, the total apparent, real, and reactive power of the circuit. First, we are to determine the current I, or the total current. So to be able to do that, we know that the current that flows through the circuit is the same. So same current at Z1, Z2, and Z3. So therefore, if we can get the current at Z1, that will be the total current. So therefore, I, by using Ohm's law, since that the voltage at Z1 is already given here and has an equivalent value of 60 cis of 0 degree volt, we are to divide this by the impedance of at Z1, that is 5 cis of 60 degree ohms. Okay, so if you are going to solve this, you can directly have it computed in your calculator. You divide 60 by 5, and that is 12, and you add or change the sign of 60 degree here, because this is from the denominator, and you will place this to the numerator, so that will become negative. So 0 minus 60, so we have negative 60 degree. So this will be your current. Now, to be able for us to determine the voltage, so we already got the current, so I'll place it in a box. And for the voltage supplied, we are going to determine here the total voltage. So we have to add the impedances. So the total impedances is actually the summation of Z1, Z2, and Z3. So that will be 5 cis of 60 degree plus 10 cis of 30 degree plus 15 cis of negative 40 degree. And it is so much hard for us if we will not convert this polar form to rectangular. So convert this to rectangular, each term here, because these are in polar form, and when you get the rectangular form, you add the real part and the imaginary part, and then we convert it again to polar form. So in doing that, we will have a result of 22.65 cis of 0.78 degree ohms negative. Okay, that will be your total impedance. Now, if you have the total impedance and the total current, we just multiplied I and ZT. So we have, okay, so I'll multiply 12 cis of negative 60 degree to ZT, which is 22.65 cis of negative 0.78 degree. Okay, so multiplying 12 times 22.65, it will give us 271.80, and we add the angle, so that will be 60 degree plus negative 0.78, same sign, so you just add it, so that will be 60.78 degree volts. So this will be the total voltage. Now if we are to determine the apparent power, the real and reactive power, okay, we just simply have S for our apparent power and B for the voltage and the conjugate of your current. So S is equals to V. Our total voltage is 271.80, C sub negative 60.78 degree. Okay, so our current is 12, but we are taking the conjugate of it, so to have the conjugate of 12 C sub negative 60, we just make negative 60 positive, so we take the opposite sign of our angle, so that will be positive 60. So we just use our calculator, if you are seeing it here. So you have 271, 271, okay, 0.80 times 12, okay, will give us 3,261, 61.6, and we add the angle, so that is negative 0.78 degree. Okay, so to be able for us to have the real power and the reactive power, we take the rectangular form of this one. So you use your calculator again and get the rectangular form, so that is 3,261.6 comma a negative 0.78 equals, so that will give us 3,261.3, and for the other part, that will be negative 44.4. Okay, so this is our result. So the real power, which is P plus JQ. Okay, so it means that our real power is equivalent to 3,261.3, and the reactive power Q is 44.4. By the way, the unit that we are using here is watts, and here volt ampere. Okay, VA, reactive, var. Okay, so since that this is negative, it means that our circuit is more capacitive. It's more on it has more capacitor. Okay, and for the apparent power, okay, for our apparent power, okay, we can use again this one, so to show to you the apparent power. So this is 44.4, and this one is 3261.3. To be able to get this one, so you have square root 3261.3 squared plus 44.4 squared. Okay, so your S is equals to you just use your calculator and just showing it to you. Okay, so you have 3261.3 squared of this one, okay, plus 44.4 squared. Okay, so I'll have the result, and I get the square root of this answer, and it gives us 3261.6, okay, BA. So these are the result. Okay, this is for the real power, and this one for the reactive power, which is more capacitive, and the apparent power. Okay, so I'll just show it to you. By the way, you can also determine the power factor, which is here, theta. So power factor is you just have the theta value, and in which you can apply the inverse tangent, okay, of this one. So that is 44.4 over 3261.3. So theta is that will be the angle. So I'm solving for the angle. 44.4 divided by 3261.3, okay, equals, and I got the inverse tangent of this one, and it gives me an angle of 0.779 or 0.7, okay, 80 degree. Okay, now to get the power factor, that will be the cosine of theta. So the cosine of this one, cosine of 0.780, that will be 0.999, and also the reactive factor is the sine theta. So this is how you solve for this problem. Okay, so again, I do hope that this gives you an understanding or an additional knowledge in solving this kind of problem. So thank you so much for watching this video.